going to give everyone just a couple more minutes before we start.
When I say Bitcoin, you say more. Bitcoin, Bitcoin.
Yeah, that's right, man.
When I say lightning, you say soon. Bitcoin has some on-chain capacity, certainly SegWit doubled the block size, so that expanded it in that way. But I think what Bitcoin is doing is going towards second layer solutions like Lightning and sidechains, and those offer 4 to 5 orders of magnitude more capacity than on-chain solutions. So I would say that is the direction that Bitcoin is going.
So Decred is taking a slightly different approach. Since we have a working governance model, that allows us to actually make these decisions a little bit later in the future. So we will see what we will do based on the data that we gather when it becomes a problem.
So Nano scales by processing transactions and organizing them individually instead of processing the transaction once and then having a block come by later. So by doing them individually, we don't have to repeat the data.
Enigma is a platform for privacy-preserving smart contract. Currently, our validation layer or verification layer is Ethereum. It scales because the computations are done in the Enigma network as opposed to in Ethereum, so we can offload the computation load and the storage load from Ethereum. And yeah, so that's that.
All right, thank you. So we're going to talk about scaling, of course, so transactions per second. So for the projects that you work with, in theory, how many transactions per second can go through your system? And in reality, what's actually the most transactions per second that's been demonstrated?
So Bitcoin, at least on-chain, does about 3 to 6 transactions per second, and there certainly have been times when that has occurred. But utilizing Lightning, you can get many orders of magnitude greater than that, because instead of broadcasting the transaction to everybody else on the network, which is required with on-chain, with something like Lightning, only the people that need to know about it find out about it. So the transmission is a lot less, and it's also privacy preserving because only the people that need to know about it know about it. And as a result, you can get way more transactions. The nice thing is, because of the privacy preserving aspect of Lightning, you actually don't know exactly how many transactions are going through. Only if you're a routing node or an end node do you know about any of the transactions that are actually happening. But you know, the testing that they've done, it's many orders of magnitude better. It's hard to say though, because of the privacy preserving aspects, to know exactly how many transactions per second are going through. But suffice it to say, it's definitely enough, because the capacity on Lightning, the people that have transacted on Lightning, it definitely works for what you know, the stores that have been there, and for money transmission and so on.
So in Decentralisation, we actually have a similar story, roughly the same number of transactions. But you are also working on Lightning. So we have created, what you will, if you will, a translation layer that translates the Bitcoin bits into Decred bits, and it allows us to run Lightning as well. So we are not quite finished with that yet, but soon, Lightning soon. But we are getting close enough that we are also going to actually release that, and we are going to use that as also a mechanism of scale.
So with Nano, there isn't an intrinsic limit on how many transactions per second that can go through it. It's primarily going to be limited by network bandwidth, and then probably I/O, and then CPU power afterwards. So in actual mainnet tests, we've done dozens of transactions per second, peaked at several hundreds of transactions per second, with some improvements that we're making in the pipeline to basically decrease the amount of bandwidth it takes to communicate. We're hoping that's going to go up. And then, of course, if we wanted to in the future add a Lightning style layer on top of it, obviously we can make use of that too.
How many has it actually done? Like how many people actually use it, and like not mainnet testing, but mainnet usage?
How many people use it? Of course,
or like what was the highest transactions per second without like actual stress testing? Like was it like with actual users?
20.
Okay.
Dozens. Yeah, dozens.
In our case, our network is specialized in computations, so it can run some fairly expensive types of computations. So really the number of transactions per second is based on the complexity of the computation that needs to be executed, so it's hard to give a number. However, it's very fast because of some attributes of our network, where only a limited number of nodes have to execute each computation at the same time. So there's limited overhead and that. So we anticipate it's going to be very fast, but we don't have a mainnet yet, and really it's based on the nature of the computation.
Cool. So let's back up to just theory a little bit. When do you know you need to scale, and how much scale is enough?
I think that's a very difficult question to answer without market participation. So when there is sort of a stress or problems on the network, or people aren't getting what they want, I think that's when entrepreneurs are supposed to step in, not necessarily like developers or central authorities or people that want to centrally plan stuff. It's more entrepreneurs that say, okay, well, these people want to transact, but they don't want to pay this much or whatever, and therefore I'm going to provide a service that's better that allows them to do what they want for a cheaper price. When there's an arbitrage opportunity, that's when people will find good business models and so on. So for me, it's not. When you find out is when entrepreneurs figure this out. When they figure out, okay, there's a profit opportunity there because there's so many people that have wanted something and they didn't get it. That's up to the entrepreneur to figure out, and not necessarily like some objective metric, quote unquote, or some, like fees at a certain dollar amount or something like that. It's entrepreneurs.
Any other thoughts on that?
Yeah, I mean, I take a different approach. Rather than kind of doing scalability as a bolt-on solution in the aftermath, I think that your system needs to be designed from the beginning to be as efficient as possible at every single layer. Otherwise, you're going to come up with substandard solutions. I mean, a second layer solution can be added to any system, and it's going to reap a lot more benefits if it's built on a system that can do more on-chain transactions per second natively.
Let's segue from that and get into the nitty-gritty of it here. So transactions per second is great, but it's meaningless if your transactions aren't secure, right? So Bitcoin has, proof of work and the longest chain, and this consensus mechanism, this security mechanism is the most well-tested and the most well-proven. So, for example, Nano, I think you used delegated proof of stake,
yep.
right? And Decred's combination proof of work, proof of stake, correct? So convince the audience that these mechanisms are secure enough. So not just that you can do that many transactions, but those transactions will be secure.
So all of these systems have a security parameter, which is the confirmation point. And the confirmation point is the point at which we say this transaction is permanent. Any additional security after that permanence is wasted effort. There's no such thing as more permanent than permanent. So Nano doesn't spend any effort trying to make something more secure after the confirmation threshold has been reached.
How's that secure?
Because it's permanent, it's reached the confirmation threshold.
It's only permanent because you say it's permanent, with the delegated proof of stakers say it's permanent. But why should we trust the delegated proof of stake nodes?
Why should you trust them?
Yeah, because they're essentially the ones that say it's permanent. But why can you trust them? Like what's to prevent them from?
Well, because if I use different transactions other than the ones that are done by those representatives, then I can't spend or use my money anywhere.
Yeah, so they're like an elite that decide whether or not transactions go through.
The only people that matter in any sort of currency is, will someone accept my currency? So I can go to them and say,
oh, that's not the only thing that matters. Oh no. Scarcity matters, decentralization matters. Like the easiness of money matters. I don't think you can say that whether or not somebody else accepts it for that temporary amount of time is the only thing that matters. That's a very method of payment oriented view. People definitely care about store value.
Are you going to accept something that has no scarcity?
No. Right, but you just said that the only thing that matters is whether or not somebody accepts it. I mean, in Venezuela, people accept Bolivar sometimes, and there's no real scarcity there. But that's not the only thing that matters. That's a false statement. But I still don't understand the security model, because if you have delegated proof of stake, you have a bunch of nodes that decide, okay, this is permanent or not, but why can you trust them? Like you just said, well, it's permanent because they say so. That's not a security model. That's just trusting in a bunch of people.
I said it matters because someone will accept my currency.
Right, so it's based on other people trusting the same central authorities. So, okay, all right, so all right, that's fair. If you want to trust the central authorities, that's fair.
So we're talking about securing your system, right? So let's talk about things specifically, like incentives on these different chains, or what percentage of honest nodes do you need to achieve Byzantine fault tolerance, right? Like, let's get specifics of what makes this secure. And not just picking on Colin. Chime in here too, Marco.
What was the question?
So what specifically makes your
Incentives.
system secure? What incentives do you have? Because from my reading, I understand that your block producers, right, don't get paid transaction fees.
Right. Yeah, so when we talk about incentives, we need to look at the incentives for all the actors in the system. So we have node operators, we have customers, and we have vendors. So Nano has a very strong selling point to vendors. I can go to them and say, if you use Nano as your currency, you will save all the credit card transaction fees that you are currently paying to them. That's an amazing concept, and every single vendor I've told that to wants to know about Nano, wants to install Nano. On the flip side, if only the node operators are getting the incentives at the expense of customers and at the expense of the vendors, that discussion goes entirely differently, because I can go into them and say, I have this currency, do you want to use it? It doesn't cost you less to do it whatsoever. And the answer is going to be probably no, I don't want to use it, I don't want to change. So the incentives need to be evened out amongst all the actors in the system, not just the node operators at the expense of everyone else.
Yes, I would agree. We are talking about incentives for adoption more than incentives for security on your chain.
Yeah, I mean,
The incentives are that the cost to send money anywhere in the world instantaneously is zero.
how's that at Byzantine Vault?
I thought we were talking about incentives.
Yeah, well,
Which one are
we're
we doing
talking
here?
about security of chains. And Marco, do chime in, please. Please, if we're not.
Also, actually, Decred uses a similar model to Bitcoin. So we are also from the Bitcoin world. We love it. We just saw some faults with it. So we wanted to iterate Bitcoin actually and add some additional things to it. And what we did is we added the proof stake component on top of the proof work. So we are a proof work, proof stake hybrid. And the point of the proof stake portion is to keep miners in check. So as beautiful as Bitcoin is, one of the things that you cannot control is a mining farm. So we have the capability of invalidating a miner's blocks if he is or she is misbehaving. For example, if you're mining empty blocks that is not desired on a network, so we could actually slap that particular miner down and say, stop doing that, you're a bad boy.
And you think that gives people greater
Sovereignty.
But it increases confidence in the security of the system.
Well, not so much as it increases confidence. What it does is it prevents certain attacks from happening. So empty blocks have been mined on the Bitcoin chain, and it's just not it's not good for network throughput. And that's just an example, right? So the idea, though, is that you need to incentivize. Let's go to the incentives. So we incentivize all the players in the system as well. So the proof four guys get the majority of the state of the block reward. But if they misbehave according to the stakeholders, then they can get stripped.
Okay. Well, let's change course a little bit, and we'll go back to decentralization. So scaling isn't really a problem, right? We can all spin up some Amazon, web servers, and problem solved. The problem is scaling in a decentralized fashion. So have there been, for some of the projects that claim to have big scalability, are there any decentralization trade-offs there?
Well, if you look at Lightning, it's actually really cleverly done so that you end up with a lot of peer-to-peer payment channels. And that's at the heart of it. So it's very decentralized in that sense. And it's in a way more decentralized than on-chain transactions, because not everyone finds out about it. If it's none of your business, you're not going to find out about it. Or you don't have to unless the transactors want to tell you about it. So in that sense, I think Lightning is very decentralized. And certainly if we go towards a sidechains model or something like that, that can also be extremely decentralized, because you would have, it's pegged to the Bitcoin chain, and only the people that are running that sidechain will know about it. And it could even be a private one, right? Like I think Blockstream has Liquid, which is based on the Element sidechain, which which is, like a private sidechain. Nobody except the people on that sidechain know about it, and it's nobody else's business. And you can do many, many transactions, and that, in a sense, it gives everyone autonomy. And that's, I think, at the heart of what makes Bitcoin different than all these other projects, is that it's largely voluntary. You make your own innovation instead of having,
I thought it was incentivized.
I mean, it's, and let people go with that instead of having some central development team that tells you, okay, this is the way it's going to be. So, for that, I mean, some projects do try to go towards more of a decentralized model than others, but that's what makes Bitcoin different, at least for me. It's all voluntary, and you don't have to use these other tech if you don't want to, and it's largely peer-to-peer based on entrepreneurs that want to build on stuff.
So let me add a little bit to that. So in Decred we have a proposal system that is off-chain, but is anchored in the chain. And on top of that, then we have actually working on-chain voting and forking of consensus rules or protocol changes. So that gives us a change mechanism to actually alter the things, but it's pretty much the same way. So you can show up with the development team and say, hey, I want to build this thing. You can actually even get funded if the stakeholders agree to it. So the stakeholders can agree to funding a development team, and then they can actually go build a new piece of software that's going to come on top of it, that they can be voted in by the stakeholders.
You need the permission of the network.
No, so it's been ish. So the number of people on the network need to be on a certain version, right? So if the network would never upgrade, then yes, you could see that as a permission.
Yeah, so it's a slightly different model in the sense that there's a vote by the community that I think the Decreds put in with their proof of stake. And I think that's like the most rational, like least scammy way of using proof of stake, right? Like if you use it to mine, then it's completely centralizing. But if you're using it to vote, at least you know what the will of the majority is, or what the will of the people that are in that system are. But at the same time, it's sort of you're terrorizing it's possible to terrorize the minority a little bit, because it's possible they want to do their own thing, and if
Is this his system or your system? He's talking, right?
So I have a lot of respect for that idea, because it is sort of based on the idea of democracy or whatever. But there is this possibility that there are volunteers that aren't necessarily self-sovereign over their own node and Decred, because you need permission.
Well, it's not technically permission, right? So if enough people upgrade their nodes, then it will move forward. So votes will start to happen. So
Only for majority, or
it's I'm gonna say 75%. I think is the number
Okay.
they put on that. So if 75% of the people of the network don't upgrade for cool new features, then yes, then that definitely would be a problem. Although we do think that we have enough width and enough people in on the project that actually would not be a real issue. And so far so good. I could be proven wrong, but I think we have enough stakeholders as well that are interested in furthering the network.
I want to hear from that. Then.
Yeah.
I want to offer it up to
Yeah, I guess I can provide a slightly different maybe angle on this on the centralization issue. In our case, we use a mix of privacy and preserving components to sort of shackle the node operators. So right now in our initial releases, we use a trusted execution environment to execute the computation. So each of the nodes of the network is executing computation in the confines of a trusted execution environment. And that's sort of a compromise between, like, it's kind of a compromise because the projects that are building on us might otherwise use things like AWS to execute these types of computation. So we enable the types of computations that are a bit more expensive that would otherwise go on AWS, but we allow the same types of computation to be done on a permissionless decentralized network using this trusted hardware. So
Okay, am I hearing this right? You are a platform on top of a platform? So you're on Ethereum and you're a platform on top of Ethereum, is that right?
Yeah, we use Ethereum as a validation layer.
Okay, right. So in that case, how are you decentralized at all? Because if Vitalik says we don't, you're taking up too much data, we're going to censor your transactions, or we're going to hard fork all of your contract away, then I mean, like you got a single point of failure there, right?
I understand what you're saying philosophically, and our goal is not also to continue using Ethereum as a validation layer forever. Like we're working on both using other chains and also having our own chain. But using Ethereum as a validation layer for now is kind of a pragmatic decision because there's a lot of development done on Ethereum. There are some applications with existing smart contracts that are built on Ethereum, and a lot of these applications currently, for pragmatic reason again, are doing some work computations on AWS because, like you said, storing data on Ethereum is expensive. Doing certain kinds of computation on Ethereum is very expensive and difficult. So we're kind of trying to approach things pragmatically, and having this network, which is decentralized and permissionless, that can be used to do things that are difficult to do on Ethereum right now. But I understand philosophically what you're saying.
Well, I mean, it sounds like centralization on top of centralization to me. If you're building on Ethereum, that's one layer of centralization, and if you're a platform, that's another layer of centralization. Anyone building on top of yours is depending on you to keep the whole thing alive. And you could probably censor things. You're saying you can't because we have some privacy-preserving features, but it's also possible that you just shut down as a platform, in which case they're screwed. So, I mean, I don't think privacy preservation is enough to say that it's actually decentralized. It's just, it happens to be that it's harder for you to censor a particular thing on the platform, but even then, if there's some sort of identifier, I'm sure there's a way to censor a particular, class of transactions. So, I don't see how it's really decentralized in any way.
I suppose I understand your philosophical argument. Like if you start with the assumption or the assertion that Ethereum is centralized, then obviously our platform is not centralized so far as it relies on Ethereum for verification. But I think that it's arguable that Ethereum is centralized.
Arguable. Okay, they bailed out people. They're imposing taxes. They're going to change incentives. Sounds a lot like government, doesn't it? Right? You can impose new taxes. Okay, we're gonna have a storage tax. We're gonna bail out the people that did the DAO. We're gonna change the proof of stake. That's about as centralized as I like.
Well, we won't argue about the centralization of Ethereum right now.
Well, I mean, we are talking about decentralization, and unless we define that, it's very hard to have this
We have an Ethereum
argument.
representative here, so we won't delve into that right
Well,
now.
he's building on it, so I think he's a good person.
I'm gonna agree with you that if I accept the premise that Ethereum is centralized and our platform is using Ethereum as a verification layer, then it's centralized. But I don't accept the premise that Ethereum is centralized.
Okay, fair enough.
So, last one, Colin, has Nano traded any decentralization for the sake of scale?
Right, so the approach that Nano takes to decentralization is we try to make the consensus model as light and as accessible as possible in order to get the most amount of people in order participating in consensus. When you do things the other way, when consensus is difficult in order to generate, what happens is you get a type of emergent centralization where many people can't participate simply because they don't have the economies of scale in order to generate the consensus mechanism. So Nano, by allowing incredibly cheap systems to drive the consensus in the network, we can make sure that anyone has access to being able to be part of the consensus and be more decentralized than solutions that are expensive.
Wait.
Right.
Your distributed proof of stake, it's just the privileged nodes that get to decide. What are you talking about? With
It's
consensus?
representative proof of stake where balance holders get to choose their representatives. So
Yeah, so it's a Senate that gets to decide.
well, it's balance holders rather than non-participating members. For instance, you would not get to participate because you don't have Nano. I would get to participate some because I have some, and then anyone that has Nano can pick their representative at any time.
But they're the ones that decide. There's no real consensus involved.
Why would somebody
people that
outside of
are-
the system get to participate in the consensus?
No,
of
no,
the
no,
system?
no.
That
But
makes no sense.
the actual people that are the DPoS nodes, they're the only ones that get to vote.
Yeah, they're picked by the people that have a balance in the system.
Right. Again, this is a Senate or an elite group that gets to decide. I don't see that how that's at all decentralized. That's centralized. Those are the people with power.
All right. So let's compare on-chain versus off-chain scaling solutions. Why would you want to scale on-chain, or why would you want to put that onto a second layer, a side chain, etc.?
Because blockchains are very expensive. That's kind of that's a very obvious reason. A lot of people on Bitcoin Cash seem to think that everything needs to be on chain because that's what's worked in the past and that's always the way towards the future. But on chain is very expensive. Blockchains are very expensive. We were talking about Ethereum earlier. When you store data on Ethereum, it's very expensive. That's because everyone has to store it, everyone has to transmit it, everyone has to validate it. This is very expensive, and if you have 1,000 nodes on the network instead of versus a centralized one, you have 1,000 times the cost. Something like Lightning is a lot more efficient. Only the two players or the people involved in the route over Lightning, they're the only ones that need to store or transmit or validate those transactions. So that's a lot more efficient. So second layer solutions, I think, are in a way allowing, by settling on the first layer, allow that efficiency, allow that additional capacity, and that's a very good thing. That's a great innovation. You could scale on-chain. That is a possibility, and we did that with Segwit. A lot of people refuse to acknowledge that, and I hate that people don't want to acknowledge that because it was a block size increase. But people don't want to say it for some reason because they didn't get their way, or they have marketing arms and they own Bitcoin.com or whatever. But the fact of the matter is, you do things in a way that's voluntary. And that's what Bitcoin does. You give everyone self-sovereignty, you allow them to choose their own way. You don't have to accept Segwit transactions, you don't have to validate Segwit transactions, you don't have to accept Segwit transactions. But if you want to, that's great, because there's a whole other economy of people that want it, and that's how Bitcoin scales, and it's based on a voluntarism.
Yeah, I totally agree with that. But I would say, it depends on the blockchain. If, for example, there was a blockchain that had shards and was super efficient in the way that it can operate, then perhaps it would make sense to do everything on the blockchain. But fundamentally, it would still be similar to a layer 2 solution where some main chain does validation while sub-chains do some more of the heavy lifting for each of the applications that are built on top of it. So, in our case, we're a second layer solution because what we do is specialize. We specialize in privacy preserving computation, and we have attributes that are fundamentally different from those of Ethereum, for example. But by using a chain like Ethereum, one that has some security properties that we may not have if we had our own independent chain, then we can inherit those properties while continuing to have the attributes that we need to be as efficient as we can. So we can do things a lot cheaper, like run computation a lot cheaper than they would if they were run on Ethereum. And we can store a large amount of data that we can store on Ethereum. So we can have our own distinct attribute while inheriting the security property of the main chain.
Great. Colin, Marco, on-chain versus off-chain?
Yeah, Nano is not expensive as an on-chain solution, and any second layer solutions that are in any other system can be applied on top of it as well. It depends on what you want to build on top of. Do you want to build on top of something that is light and fast, or do you want to build on top of something that is slow and expensive?
Man, I'm sitting right in the middle of this one though. So, no, it's true though. So we are a traditional blockchain in the same sense that Bitcoin is. So on-chain is expensive, and you want to only put stuff on there that really needs I'm okay with chain space being scarce and expensive.
Okay, cool. All right, we're going to do one more question. So back to the focus on security, right? Proof of work is seen as necessary because it's what makes Bitcoin secure. But it also gets a lot of criticism for wasting a lot of energy. So is proof of work necessary, or would it be fantastic to have a chain that did not require that sort of energy input?
If you're centralized already, proof of work doesn't really make that much sense. But if you are decentralized digital scarce money, then yes, you need proof of work. It's a feature, not a bug. You want money to be hard to produce, because otherwise people go into the money production business. And that's something I talked about in my previous talk over here. But it's a feature, not a bug, when you have decentralized digital money. For a lot of other stuff, it doesn't really make sense. You are kind of wasting, if you're not trying to be hard money, or if you're not trying to be simple money, then maybe a centralized system works better. And I think that's what distributed proof of stake is. It's a centralized system. And you don't need proof of work if you have a centralized system. Of course, if you are completely centralized and have like a central database and everything, that would be even more efficient. And I think whatever your project is, you're ripe for disruption by something that's completely centralized and do it more efficiently for less money if that's the direction you're going in. So proof of work is necessary for hard money, which Bitcoin is. For other projects, I don't know if it makes sense.
Yes, for the same reasons that Jimmy said, I actually agree with that statement. So I also think that it is expensive. The debate is a bit overblown at this point. I've seen a lot of faux analysis, if you will, going on. I don't know. I am unconvinced that the amount of energy spent is accurate.
Yeah, they just multiply numbers, right? I mean, a lot of the energy that these miners use is excess capacity. It's waste heat that would have gone into the atmosphere.
There's an opportunity cost to that too, because that could have been spent on something productive.
Absolutely. But if you call proof of work productive, then it is productive.
Yeah, like talking about the money is worth it because how much money went into mining it also doesn't make economic sense. That's talking about the labor
you don't
theory.
know economics.
It's talking about the labor theory of value. How hard is it to do something? Is that how much it's worth? It actually is what is the demand theory of value? Is how much does somebody want this? So it's a property of how much does somebody want to use your Bitcoins. That's what gives the value. It doesn't matter how much energy was spent to produce them.
And that's a terrible view of economics that's not supported by anything in history, so that's fine.
Please quote
you believe that, let's see
Please
how that
write that
works.
down. That's his quote.
All right, well, I think we are at time, which is a shame because that was a very lively conversation. So thank you, gentlemen.
Okay.